Okay, I think we're going to get started here. Thank you so much for attending this session. I know it's one of the first sessions after the keynote, so it was hard to predict how many people are going to actually show up. So appreciate you guys coming to our session today. I'm Praveen Pillai. I'm a senior product manager at AWS, and I focus on the search and analytics space at AWS. My co-presenter and colleague, John Handler, unfortunately had to cancel his trip to reInvent to take care of something important. So John, we're thinking about you and your family. We'll see you soon. So we're here today to talk about Elasticsearch. And it's an especially exciting time for us to talk about Elasticsearch because, as some of you might know, we launched Amazon Elasticsearch Service just last week. Amazon Elasticsearch Service is a managed service from AWS that makes it easy to deploy, operate, and scale Elasticsearch clusters in AWS. Now, we're going to spend a lot of time with this session talking about a lot of the features and functionality that the service offers. Again, we'll do as much as we can, but if you have any questions, feel free to reach out to us after the session. We have representatives in the AWS Big Data booth as well as the new services booth, so we would love to have a chance to talk to you and answer any follow-up questions you have. Before we get started, though, just a quick check. How many of you here already use Elasticsearch extensively? Just show of hands. All right, a lot of people here. That's great. Glad you could make it. But just to set some context for both the people who use Elasticsearch as well as those who don't, I want to spend a few minutes just talking about the types of problems that Elasticsearch can help you solve. And then we'll spend the rest of the session really diving into the features of Amazon Elasticsearch Service, how you can use the service to solve your big data problems, how you can set up clusters, how you can configure them, secure clusters, monitor them, how you run Kibana, a bunch of different things. So we'll walk through all that in this session. So again, just to set some context, I'm sure all of you in some form have run into this problem with data. Cloud computing and all the associated technologies around cloud computing in the last 10 years have really made it very, very easy and cost-effective for us to collect data from a variety of different sources. So what we've done is take advantage of that and really instrument a ton of different services and systems in our ecosystem to really emit data, lots of data at high speed, at high volume, with a lot of variety. Data like product usage data coming from your application. So you could have your application sending in information about how your users are using your application, where they're running into problems, the most popular features that you have. All of this can be instrumented and collected from your application. Or you could have data coming in from different services or systems that are log data, tons of data with a lot of different variety and formats that are telling you about what's happening in your ecosystem. And this could really quickly grow into terabytes, if not petabytes of data, as you probably know. And then you can have another scenario where you're collecting data about customer conversations. This could be things that are coming in from your CRM system, from your support organization, maybe through social media, or even your field sales team that are telling you about how your product is resonating in the market, what is really the product market fit, is it really working? Lots of important data that's, that you could use for your strategy in your business. Now, this is just a few examples. Right? I'm sure you've got tons of other ways and reasons for collecting data. But ultimately, the problem is you have a ton of data. And this problem is only getting worse. The amount of data collected across the world is expected to grow something like 40x over the next 5 years. That's a lot of data. What are you going to do with this data? What can you do with this data? You probably do some of this already. I mean, you can do a lot of things, right? You can share this information. You can extract insights from it. I like this quote that I came across on the internet from Gary King at Harvard University. It says, "Big data is not about data." I think what he's actually trying to say is it's not just enough to collect information from all these different places, collect data. You've got to do something with it. You've got to do something with it to extract value and really drive value for your business. Right? So you can do things like sharing information and extracting performance data or tracking insights. So you can do a lot. But ultimately, what you want to do is make sure that you're leveraging the data to help you make better technical or operational or business decisions. Let's look at a couple of specific scenarios, right? So one could be a knowledge sharing system that you want to build. So this is a task that you've been given. You want to make sure that you're helping your team share information with each other and also find information that other people might have created. For this particular problem, you may want to build systems that have powerful search technologies, search features. You also need to have a variety of data ingestion options so that you can ingest data in different formats that your users are creating and make them available for sharing and searching. Another scenario could be you are tasked with building or protecting your ecosystem from intrusion. So you have to be able to ingest data at very high speed, be able to analyze that data very quickly, and identify patterns or intrusions or some sort of anomalies so that you can protect your ecosystem. So it's a very important task, a very important use case, right? So you don't want to have something bad happen to your ecosystem. So that's another use of data and what you can do for your system. Or maybe you're a mobile app developer and you've got a hit application out in the world. You've got millions of users, multiple versions out in the wild, and you've got to track usage across all these different versions. You've got to process information coming in from your users, maybe look at how they're migrating from one version to another. So that's another scenario where you're trying to make use of data. What options do you have to solve these types of problems? Now, there's probably tons of technologies. I didn't even attempt to put all the different options on the slide. I just wanted to call out a few popular open source technologies that you can use for big data problems. And without going into a lot of compare and contrast on these things, I really just wanted to pull out one technology and talk about it more, but obviously Elasticsearch. So what is Elasticsearch? Elasticsearch is a powerful open source search and analytics engine. It's built on top of Apache Lucene, so it comes with a ton of different search features that makes it really, really useful for a lot of different use cases. In addition, it has a very easy-to-use REST API. It can handle both structured as well as unstructured data. And it has a lot of built-in analytics features as well, things like aggregations, which makes it very, very useful in analytics workloads. Essentially, it lets you explore data at very high scale. In addition to Elasticsearch, the core technology itself, as you know, there's a very rich ecosystem of tools around Elasticsearch, particularly Logstash for data ingestion, Kibana for data visualization. This makes the entire stack very, very useful to solve problems like the ones I highlighted just a few minutes ago. But operating Elasticsearch is time-consuming. We repeatedly hear from our customers, just like any other system, operating Elasticsearch in production takes a lot of time and effort and takes your resources away from doing something more value-added for your business. It's undifferentiated work that you have to end up doing to manage a cluster of Elasticsearch servers for your ecosystem. And customers have repeatedly asked us for solutions to offload this administrative burden from them so they can, again, focus on things that are important for their business. So again, we're super excited to have this product in market. It just launched last week, Amazon Elasticsearch Service. And our goal is to make it easy to deploy, operate, and scale Elasticsearch clusters in AWS. Now, we're going to spend a lot of time talking about individual features and functionality in the service and kind of walk through the whole sort of life cycle of creating a cluster and managing it and securing it and loading data and such. But before we get into that, I wanted to first just highlight a few major categories of features that we have, benefits we have in the service. Number one, it's just easy setup and configuration to get started. So we have easy-to-use console UI, simple APIs to create your cluster and get going very quickly. In terms of the Elk stack, we have support for the Elk stack. So obviously, it's a managed Elasticsearch service, so we run Elasticsearch for you. The service also comes in with built-in Kibana. So if you want to use either Kibana 3 or Kibana 4, they're both available with the service built in. You don't have to run your own Kibana servers. In terms of Logstash, we have simplified the process of how you can run Logstash with the service. And what I mean by that is we actually have released an output plugin for Logstash that does request signing automatically, so you can connect your Logstash instances to your domains running on Amazon Elasticsearch service. And we'll look at that more in detail here. The third category is around security and monitoring and auditing. We'll again dive into this a bit more, but we have integration with AWS IAM for controlling access to your domains, and you can control access at multiple levels. We have integration with Amazon CloudTrail for auditing management commands coming into your domain. We have integration with Amazon CloudWatch for monitoring and metrics, so you can keep track of the performance of your cluster. In terms of data source integrations, we have a variety of options. We have integration with Amazon CloudWatch. We'll talk about that as well. There's options to connect to your data in DynamoDB or S3 or Kinesis. So we have lots of different features here. So those are the highlights. The next several minutes, I'm going to walk through sort of the process of creating clusters and configuring clusters, securing clusters, take you through the whole sort of life cycle here. So let's start with creating a cluster. I mentioned that it's super easy to get started. So what does that look like? So this is screen up here is a screen cap of our create domain wizard. As you can see, it's very simple UI. You can get started very quickly with just some of the default values we have, or you can fine-tune and configure the cluster to match your specific workloads. So let's talk about what that fine-tuning really means. The first option you have is to be able to choose your node configuration. And there are two types of nodes you can set up. The first is data nodes. Data nodes are the ones that hold your data and respond to the queries that come into Elasticsearch. You have the ability to configure the data nodes here with the type of node you want and the number of nodes you want to allocate to that particular function. In addition, you can also set up dedicated master nodes. Now, master nodes are nodes that are their primary responsibility is to help ensure cluster stability in Elasticsearch. So they hold some sort of metadata information and really manage the stability of a cluster. So you have the ability to set those up specifically as well, and you can have a different type of node for your master node versus your data node. We highly recommend in any production cluster that you actually have dedicated master nodes to make sure your cluster is as stable as possible. We have options for storage. So you can either use the on-instance local store to store your index, or if you choose, you can use EBS as well to store your index, so you can independently sort of scale your compute and storage resources. There's a feature called zone awareness. So when you enable zone awareness in a multi-node cluster, what the service does is it automatically distributes the nodes in your cluster into two different availability zones. So then if you have replication set up, your replicas are automatically put on different nodes, which are already in different availability zones, so you have a higher level of availability or redundancy built into your service. So it's just a matter of clicking that one checkbox, and that's done for you. This UI also lets you set up configurations around your snapshots. So we'll talk about backup here later in the presentation, but through this UI, you can also set up the snapshots, the time that you want the snapshots to occur in your domain. So that was the UI, and this is a look at all of the APIs that we offer from a configuration standpoint. As you can see, it's super simple. You have create domain, update domain, delete domain, or describe domain, so those four actions that you can perform on the domain itself. One thing I didn't talk about, it's the tagging feature. So the service also comes with resource tagging capability. So just like a lot of other AWS services, you're able to tag your resources specifically, and so you can audit them later for cost control purposes and others as well. So we have about 3 APIs from a tagging perspective. So very simple, clean API from a configuration management perspective. And the example here shows you how easy it is to create a domain using this API. With that one call, you can create a domain that has 3 M3 extra large data nodes with EBS as the storage option. So that's what the example is about. So I kept talking about domain. So let me kind of explain what a domain is real quick. This is not an architectural diagram. It's just meant to sort of pictorially represent what a domain stands for. So an Amazon Elasticsearch service domain is essentially, it's made up of the nodes that run your Elasticsearch service. And it has the software that powers the cluster, essentially both our internal software for management as well as the Elasticsearch software itself. It contains the load balancers, the security and auditing and monitoring systems. All of those are part of what make an actual Amazon Elasticsearch domain. Let's look at each of these in more detail. So the first one is the nodes under management. So we talked about the 2 different types of nodes that you can set up in your cluster. So the first one is the data node, which holds the data, responds to queries. The second is the master node that manages cluster stability. The service is going to manage all these nodes for you. So it's going to continually monitor these nodes. And if a node does fail, it's going to attempt to recover it and recover the nodes where possible. So these nodes are completely managed by the service. The next piece is the access to the nodes themselves. So we have an ELB in front of the nodes, and the ELB is used to load balance traffic coming into the cluster. There's an entry in, there's a DNS entry in Route 53, so you have a single endpoint that you can use to connect to the cluster over HTTP. And the service supports the Elasticsearch API. So the same API you use today with your applications can be used with the service as well to create and manage indexes or upload data, run search queries, all of that stuff. So you can use the same Elasticsearch API. So super important. Single endpoint, support for the Elasticsearch API. In terms of security, I mentioned it briefly. We have integration with AWS Identity and Access Management. That's the way you control access to your cluster. And you can do this at multiple levels. You can control access at a domain level, or you can do it at an index level, or you can even set up specific controls for different Elasticsearch APIs that you want to maybe provide access to some users but not to other users. And we'll walk through examples here in a minute. And finally, we have integration with CloudWatch and CloudTrail for monitoring and metrics and auditing, as I mentioned earlier. So that's sort of the high-level picture of what a domain essentially looks like. Now that we talked about the domain and the creation process, I just want to spend a couple of minutes talking about the process of actual scaling and how that works, and also some things to keep in mind when you think about how to configure your domain. So let's talk about scaling first. Once you set up your cluster and it's active and running, you can make changes to your configuration at any point. You can add nodes, you can change storage settings, you can change your access policies. And all of this is done for you in an online fashion. So when you make those changes, the service will spin up additional nodes with the right properties, the updated properties. It will replicate the data. And once that's done, it will spin down the old nodes. So all of this is done online. There's no disruption to your service. Amazon Elasticsearch service will take care of all that for you. In terms of other things to keep in mind when you have to go through your cluster configuration. So one of the things, obviously, is just how your data is structured, right? So just a quick background. This is probably familiar to a lot of you in the audience that are search people. But the data that is stored and searched in your domain is essentially stored as an index, right? The index is the data that you are using and storing and searching on. The index itself is made up of one or more shards of data. So a shard is essentially just a partition of your large data set. And each shard is made up of multiple documents. So the document is the unit of data that you load in to your system. And it's the unit of data that is returned to you as results from your search and analytics queries. And finally, the document has attributes like fields or document IDs and stuff like that. So let's look at a specific example. In this example, We have index 1 and index 2. Index 1 is in green, index 2 is in blue. They both have 3 shards in this example. And each of the indexes also has a replica. So what that means is each of the shards ends up having a replica. So you have a primary set of shards and a replica set of shards. So the primary shards are the ones that have the bold border on them, and then you have the replicas. The primaries are the ones that would sort of control the reads and writes into your index. The replicas can be promoted to primary if needed, if the primary goes down for some reason. So one thing to keep in mind here, and the reason I brought this up is, if you allocate enough nodes to your cluster, in this case 3, then the service is going to make sure that your primary shards and your replica shards are distributed to different nodes so that you have some level of redundancy. So in this example, you have index 1, primary shard 1, and instance 1, and index 1, replica shard 1, and instance 2. And you can see that's sort of done for the other ones as well. So the service is going to do this for you automatically. So you want to make sure that you have enough nodes in your cluster to let the service do this for you and create redundancy. If you don't have enough nodes allocated to your cluster and you have replicas set up, one thing to keep an eye out on is your cluster status. It's going to be yellow. So if you see a cluster status yellow, you want to kind of check and see if you have enough nodes allocated to your cluster. Another thing to keep in mind, if you're using Logstash and you're using Logstash to push data into your Amazon Elasticsearch service domain, Logstash actually automatically creates a replica of your index. So if you don't have enough nodes, again, it's going to go yellow. So just keep an eye out on that as well. How you set up your shards and how many shards you set up really has a lot of impact on the configuration of your cluster. So you want to really think about that. The size of the nodes, the size of the storage options, all of those will be impacted by how you set up your shards. In terms of instance types and storage options, the service provides multiple options for you. For instances, we have the choices between T2s, M3s, R3s, and I2s. So each of those work better for different types of workloads. T2s are great for dev test workloads. You can also use T2s for production, especially the larger ones. And you can also use T2 nodes for dedicated masters that we talked about earlier. The M3s are general purpose instances. They provide a balance between networking and memory and compute, and they work for a lot of different variety of use cases. R3s are memory optimized instances. They work great for use cases that have complex query demands. If you're running a lot of aggregations, for example, or you're running a lot of things through Kibana, maybe you want to think about R3s. I2s are storage optimized. So they're backed by high-speed SSDs, great for random high I/O. With I2s, you can actually create clusters up to 16 terabytes in size. So if you have a large data set that you want to make searchable or want to analyze it, you can use I2s. Actually, before we get into the next topic, just in terms of storage options, I mentioned that we have both on-instance local store that you can use as well as EBS. So we support all versions of EBS, so all different types of EBS, magnetic, standard, PIOPS. And in terms of the size of EBS volumes that you can attach to the instance, it really depends on the instance type that you select and the instance size. But EBS is an option for storing your index. OK, so we talked about configuration, some things to think about in terms of how you configure your cluster. Let's talk about security and how you secure your cluster. As I mentioned before, the service comes integrated with AWS Identity and Access Management, and that's how you set up access control for your domain. And you can set up access control at multiple levels. You can set up at the domain level, down to the index level, or even individual Elasticsearch API, so you can control who has access to what. There's an example policy here that we'll go through in more detail. So in this example policy, we have the principal element that we're using to specify which user has access to whatever action we want to give them access to. So this is a user policy, a user-based policy, and we're specifying the user that has control to do what we're allowing them to do. The action element in this policy specifies what we want to let that user do. In this case, we're giving them access to be able to execute certain HTTP commands, get, put, post, and then a couple of the management APIs that we have available. So we're giving this access sort of limited control to what they can do. And finally, we use the resource element to specify where they can execute these types of commands. So this is where I was talking about. This can be a domain, it can be an index within a domain, or it can be even something more fine-grained than that. So this user policy is allowing this user to do those actions on a particular index. You can change this policy to, instead of having it as a user policy, you can have a wildcard for the ARN, the Amazon resource name, and make it more open, if you will. You can also do IP-based access control if the use case asks for it. In this case, the changes to the policy, as you can see in the principal element, we use the wildcard. The action and resources are the same, but then we have a condition element where we specify the IP address or the range of IPs that we want to let these types of requests come in from. So once you set up this policy, any requests coming in from the IP ranges that you specify will be allowed to do those actions that you give them access to. So that's kind of how this security or the securing policies work. Okay, so we talked about creating domains, configuring them, things to keep in mind when you configure your domain, how to secure your domain. Let's get to some of the more fun stuff. I mean, so ultimately we want to get data loaded in, and we want to be able to analyze this data, right? So loading data. What options do you have for loading data? There's a variety of options. I will go through some specific, some of the more important ones here. The first one is direct access to the Elasticsearch API. So clearly, the service supports Elasticsearch API, so you can use Elasticsearch to load data, right? So the commands here are just some sample commands, by no means exhaustive, but the commands here show how you can post data to an index or do bulk post, for example, and finally run some searches to get results from the index that you've just created and loaded data into. So the important piece here is the service supports the Elasticsearch API, and you can use that to load data. Another option to load data is Logstash. So I'm sure almost all of you are familiar with Logstash. It's an open source project. It's essentially a data pipeline that lets you process logs and other sort of event data from systems, and then do some sort of transformation on the data and load them to different endpoints. Elasticsearch is one of the endpoints it supports. So in this sort of data flow diagram, if you will, what we show here is application nodes that have Logstash forwarders or Lumberjack running on them. And these Logstash forwarders are forwarding some kind of data from your application nodes into another Logstash instance that could be doing transformations using some sort of transfer plugin. And then it uses an output plugin to push data into a domain in Amazon Elasticsearch service. So I briefly mentioned this before. So we've actually launched an updated Logstash output plugin that works with our service. You can download that on GitHub today. This output plugin makes it easier for you to connect your Logstash instance to the service. It automatically does request signing for you. So you can see the configuration setting here on the screen. You just have to mention the URL where your domain's running, and it automatically picks up the access key and secret key from your environment and executes the commands. Another option for loading data is Lambda. So if you have services that you're using as data sources from AWS that are already integrated with Lambda, so S3, Dynamo, Kinesis. So if you're using one of those data sources, you can write a very simple Lambda function that gets triggered when there's some kind of an update on one of these data sources, and then pushes data over to your domain in Amazon Elasticsearch service. One thing to keep in mind, Lambda is only available in select regions today, so this functionality is limited to those regions at this point. A quick look at a sample Lambda function that you can use to set up data. into your Amazon Elasticsearch service domain. Again, this is just a node.js snippet. We have a lot of code samples available in GitHub. You can go take a look at it. Similar to the previous one, it does signing automatically for you, and you can do whatever transformation you need to do in this function, and then have it load the data over to Amazon Elasticsearch service. Okay, so the next data ingestion option I want to talk about is the integration with CloudWatch logs. So quick show of hands, how many of you use CloudWatch logs? Okay, more of you should use it. It's a great product. It lets you sort of collect your log data in one place and analyze it and do a lot of things with it. One of the frequent asks that we had from customers was they wanted an easy way to do a lot more deep analysis and exploration of the data that's being collected, the log data that's being collected in CloudWatch logs. So the CloudWatch logs team worked with us and released a new feature last week when we launched our service. Essentially, with this feature, you're able to go into CloudWatch logs and very easily set up a streaming mechanism that pushes your logs data into your domain on Amazon Elasticsearch service. So let's take a quick look at a demo, and I'll walk you through how this works. As you can see here, we have a domain already created on Amazon Elasticsearch service. When you click on the domain, you can see the properties of the domain, including the URL for Kibana. Now let's take a look at the source of data that's going to power these logs. We actually have an instance running on EC2 inside of VPC. It's running JMeter and emitting some sort of some information that we will then log and analyze. When you go into the VPC console, you'll be able to see that there is a CloudWatch logs group set up for this data coming from that instance. When you go into the CloudWatch logs group, you can look at the log stream, and you can click on the log stream to actually see what the data in the log actually looks like. So that's all the setup. Now, if you want to stream this data into your Amazon Elasticsearch domain, all you have to do is go back to the log group. When you click on the log group, you'll be given an option for an action, and in that action, you just select the option to start streaming. You'll come across another UI option that lets you select from your existing active domains. You choose that. You then pick the log format that you want to use. This UI also lets you test your patterns, make sure that the data is what you think it should be. Once you have that ready and tested, all you have to do is just click on the Start Streaming option, and that's essentially it. So now all your data, the data that you have in CloudWatch logs, can be streamed over to your domain on Amazon Elasticsearch service. Now going back to the domain in the service, you can look at data coming in, the JMeter log group in this case, and you can also go to Kibana and now start visualizing the data and analyzing it in any way that you want. We've actually built some pre-built dashboards for things like VPC flow logs and CloudTrail logs. So if you have those specific logs that you want to use in this instance, you can use the pre-built dashboards that we have. There's a couple of blog posts out there that tell you how to get access to those dashboards. But essentially, you're able to now connect your data from CloudWatch logs into Amazon Elasticsearch service. So that's a new feature we just launched with the service last week. Let's get back to monitoring and auditing. I briefly mentioned this a couple of times. So we have integration with Amazon CloudTrail for auditing purposes. So essentially what CloudTrail does is it logs and records all management calls being made to your domain so that you can track it later and see who's trying to do what in terms of management on the domain itself. In terms of Amazon CloudWatch, we have a bunch of different monitoring capabilities built in and metrics that are exposed to you through CloudWatch that you can use to really monitor your domain and see how it's performing and take any corrective action you might have to. So let's kind of focus on CloudWatch here real quick and look at what's available. So the service actually emits 17 different metrics about the performance of your domain to CloudWatch. The screen just shows you a couple of ones here. Those 17 metrics, you can access them either through the CloudWatch console or through the monitoring tab in the Amazon Elasticsearch service console. You can also get access to those metrics through the API, through our SDK as well. Now, I just want to highlight a few of the metrics that you may want to keep a close eye on. The first one is free storage space. So this essentially tells you how much storage you have available or left in your domain as you keep loading data. So if you're getting to a certain threshold, you may want to increase the storage volumes or the size of the storage volumes or add more nodes or do something to allocate more storage to your cluster. So something to keep in mind and keep an eye out on. The CPU utilization and JVM memory pressure metrics usually are signals that you want to probably scale your nodes in your domain. So you may want to add more nodes or increase the size of nodes if these get past a certain threshold. We have cluster status, again, that's yellow, green, or red to keep an eye out on any problems happening in your cluster. And we also have a separate set of metrics for master nodes. So we talked about dedicated master nodes that you can set up for your domain. And if you do have the dedicated master nodes set up, then you'll have a specific set of metrics with the prefix master in them that are metrics associated with those master nodes. A couple of final features real quick. Snapshot restore for data durability. I mentioned that the service provides automated daily snapshots. So this is done automatically for you. There's no additional charge. These daily snapshots are stored in an S3 bucket that the service owns for a period of 14 days and can be used for sort of recovery, operational recovery purposes. In addition to the automated snapshots, you can run your own manual snapshots as well. So in any frequency that you choose. And you do this through the Elasticsearch API for snapshot. And you can restore from these snapshots using the restore API. So any manual snapshots you take are stored in your own S3 bucket. So any cost allocated with that or associated with that is on you for these manual snapshots. To set up manual snapshots, you've got to do a couple of things from an access control perspective. The first one is you want to establish a trusted relationship between the service, Amazon Elasticsearch service, and your account. So you can do this in IAM, but essentially saying that your account trusts the service. The next thing you have to do is allow the service to be able to write to your S3 buckets. Because when you take a snapshot, you're taking it off your Elasticsearch cluster that's running in the service, so you need to allow the service to write to your own S3 buckets. So the policy on the screen here just shows you an example of how you can do that. Once you have the policies, the access control set up, then you can use the Elasticsearch API directly. So first, you need to register your bucket with your cluster. That's the Elasticsearch register command that's up there. And then you have to, and then you can run your snapshot API. So you can run your snapshot against the domain, and it's going to store that snapshot in your S3 bucket. One thing to keep in mind, pretty sure it's obvious, but the snapshot time is proportional to the data size. So if you've got a large data set, you may want to think about what frequency you want to run these manual snapshots in to make sure you're not overloading your cluster. So finally, I want to talk about Kibana. So the data's all there, the domain's running, you're monitoring, everything looks good. Ultimately, you want to see some pretty pictures, right? So that's where Kibana comes in. So the service has Kibana 3 and Kibana 4 built in, as I mentioned before. You don't have to run your own Kibana. You can use the built-in Kibana that comes with the service. And real quick, whoops. So just real quick in terms of how data gets to Kibana, right? So you have, this is just one way, I'm sure there's lots of ways you can get data in, but you have your users using your application. The application is talking to your servers in the back end. In addition to a lot of other things that the servers are doing, they could be running Logstash forwarders that forward some data to another Logstash instance, which you use for transformation, and then you push data to your domain on Amazon Elasticsearch service, which comes built in with Kibana. So now you're able to visualize this data. This is a quick view of a dashboard on Kibana 4. We've got this built for VPC flow logs, like I mentioned before, and a couple of other log types. It's available to you to use. So this dashboard here shows you data coming in from VPC flow logs. And you can look at things like accepted or rejected packets or sources of traffic coming into your nodes that are running inside of VPC. So again, just a bunch of different pre-built dashboards that might be useful to you. But ultimately, this is the kind of analysis you can now do with Kibana and with Amazon Elasticsearch Service, right? All this data that you were collecting before was just a ton of data, but now it's in a useful format. It helps you get some deep insight and make better decisions for your business. One question that comes up frequently when we talk about Kibana with our customers is, how can they provide authenticated or controlled access to Kibana to certain users? Not all of you may want to do this, but we've had enough questions about it that we thought we'll talk about it for just a minute. One way to do that sort of authenticated access control for Kibana is by using a proxy in front of your domain. So if you have a proxy, you can do some sort of login password-based user authentication that you build yourself. It's not available with the service today. You have to build this sort of proxy yourself, but you can do that. And then from the proxy to the domain, you can set up some sort of IP-based access control, if you will, using our IAM policies like we talked about before. So again, I'll look at an IP-based access control policy that you can use here. You see the wildcard for the principal, the actions mentioned, the resource against which you're executing this policy, and finally the IP address list from which traffic is allowed or requests are allowed to come into the domain. So we talked about a bunch of stuff. How to create Amazon Elasticsearch Service domains, how to configure them, how to secure them, how to load data, how to use the data visualization tool. All of this is available to you on a pay-as-you-go basis, right? Just like any other AWS service. You can configure your compute and storage and scale them independently and only pay for what you use. Amazon Elasticsearch Service also is part of the AWS free tier. So if you have a qualifying account, you can get started for absolutely free. The service is available in GA today. As I mentioned, we launched last week. It's available in 9 different regions. So hopefully region availability is not a blocker. And finally, in wrap-up, Elasticsearch is a great piece of technology. It's a powerful search and analytics engine. You can do a ton of different analytics on data to help solve problems that we talked about earlier and really gather deep insight and leverage data to help your business do better decisions or make better decisions. Amazon Elasticsearch Service makes it easy to deploy, operate, and scale Elasticsearch in AWS. Amazon Elasticsearch Service supports the Elasticsearch API, so it's a drop-in replacement for any Elasticsearch clusters you're running today, but on your own. The service is available in GA. We hope you check it out. We would love to hear your feedback. Please get a hold of us either at the conference or through our forums and other means. We would love to hear your feedback and see what else we can do to help you with Elasticsearch. Thank you for attending this session. We're available for any Q&A. If you're interested, you can also find us at the booth. Thank you.